Friends, before we invite our next speaker, Mounesh, we will now take our second poll question. So, may I request, Manohar, if you can kindly share the second poll question? Yeah. So, which of the sectors will predominantly accelerate the demand of the advanced measuring and the inspection systems in India? So, there are four sectors: automotive, aerospace and defense, electronics manufacturing, and medical devices. Let's see what the audience will like. Okay, let's see the results if it is ready now. Yeah, it's a close call, I think. So with automotive and aerospace are tied, and versus electronic manufacturing, medical devices not. So I think with this analysis, I think you will get a better view, Mounesh, with the
yes
for the audience. So over to you, Mounesh, for your presentation on non-contact industrial measurement solution for electronics, automotive, and general engineering. Over to you, Mounesh.
Yes. Yeah. Thank you, Sandeep. Okay. Are you able to see my screen?
Yes, Mounesh.
Okay. All right. Just give me a sec. I mean, all right. Good afternoon to delegates, VDMA team, and all participants. My name is Mounesh. I'm a PSM and channel management responsible for 𝐏𝐡𝐨𝐧 India, and presently I'm speaking from 𝐏𝐡𝐨𝐧 India, Bangalore. And today, firstly, before starting my presentation, I thank VDMA for organizing this web seminar and giving us an opportunity. This is the agenda of what I would be trying to cover in this session. For those of you who are not aware of ZEISS, I just want to spend a couple of minutes about what is ZEISS all about, what is our presence and how is our presence in India, and what are the solutions we offer. Then I will talk about some of our non-contact solutions, which are basically light-based, not a contact-based, light-based or optical-based, or solutions which could be used across industries for various purposes, like non-destructive testing using X-ray, inspection of connectors, for example, with the optical means. Then inspection of PCBs. For PCB, for electronics manufacturing industries. Then non-destructive failure analysis, how it can be done using our X-ray solutions, and also microscopy solutions for metallurgy and technical cleanliness applications. So all these solutions are what I'm talking about. Today's session is are not our regular contact-based solutions, but these are all based on our non-contact, optical-based or X-ray-based solutions I'm going to talk on. So quickly to move forward, 𝐏𝐡𝐧 is basically a German company established in 1846. The company is named after the founder, from Mr. 𝐏𝐡𝐧. Then for the people who are there in the field of physics or in the academics, everybody must have known about a scientist, famous scientist, Ernst Abbe. In fact, Ernst Abbe is also the founding member of 𝐏𝐡𝐧. So he is done, and we study about the Abbe theory in physics in our academics. So he's the same gentleman, okay, who is also our founding member. Coming to the 𝐏𝐡𝐧, the overall market, so the business segments, we are into semiconductor manufacturing technology, industrial quality research, medical and consumer markets. So semiconductor manufacturing technology, just to give an idea, almost 80 to 90% of the integrated chips being manufactured across the world, which are being used across all our electronics day in, day out, are manufactured using a lithography technology, and one company named called ASML is the leader in this lithography technology. And this ASML company uses ZEISS optics and system doing the operation, something called as extreme ultraviolet etching technology, which is their uh, uh, which is a very renowned technology and used for manufacturing the semiconductor chips. And coming to industrial quality and research, we have again industrial quality solutions and then research microscopy solutions. I come from industrial quality solutions, and today what I'm going to talk about is the solutions for industrial quality related. Of course, we have medical technology and again consumer markets. Consumer markets is nothing but eye spectacle lenses, what you might have seen, and also the medical technology deals with all ophthalmology related field and surgical microscopes. So ZEISS, over its centuries of existence in the market, okay, has enabled many innovative solutions, has offered many innovative solutions and enabled the companies with many innovations. Like for example, 80% of the chips what I mentioned, okay, are being manufactured right now today are from ASML through lithography technology. Then 35 Nobel laureates used our microscopes, which helped them to do the research successfully in their area of pursuit. Then 50 camera lenses were set into space, okay, when the first NASA mission took place, and almost 15 million operations worldwide are being surgical operations done by using ZEISS Medical Technology Division. And 10 Oscar-nominated movies were shot through ZEISS cine lenses in the year 2019. So coming to our presence across, we have global presence with more than 30,000 employees, 100 locations, and presence across 50 countries. And the one thing, of course, company is almost 7 billion euros company, 𝐒𝐶𝐬𝐧 put together. Very important thing is our R&D investment. Our R&D investment is almost 11% of the revenue, which itself speaks of the solutions products coming from 𝐒𝐶𝐬𝐧 are highly innovative, and they are all state of the art, which meet the present day demands of the industry. Now coming quickly, that is all about our 𝐒𝐶𝐬𝐧 group. Now if I talk about the industrial quality solutions, that is our division specifically. So ZEISS started way back in 1846, but then in the year 1919, ZEISS used their optics. ZEISS was famous for the superior optics when the company started, and those optics were used on one of the metrological instruments way back in 1919, and that's how the ZEISS journey in industrial metrology began. And we proudly say now that we have more than 100 years of experience in the industrial metrology. And very significant achievements for us in the industrial metrology field are the scanning technology, what we introduced in our CMM way back in 1974. This is the first CMM ZEISS introduced in 1974, and one of the best revolutionary technology what we introduced was the scanning technology. With the touch scanning, till the time there were no scanning technology available. This helped the industries to a great extent to measure the parts more precisely, and also enable the production companies to look more closer into the dimensional deviations in the parts what they are manufactured. So naturally, all the manufacturing companies gained a lot of benefit from this technology, and they could able to identify where they are going wrong, and they could able to correct their mistakes and then do the manufacture the parts closer to more tolerance, nominal values. Yeah. So about our markets, okay, we are into aviation, energy, automotive, and microelectronics, and put together, I would say we are the market leaders globally with almost 34% market share. And coming to the product portfolio, this is a bird's eye overview. We have the product portfolio covering from conventional bridge type CMMs, then production CMMs. These are coordinate measuring machines which can be directly used in the shop floor as well. Then we have large size coordinate measuring machines, multi-sensor measuring machines with contact as well as non-contact put together. Then we have 3D scanners, then horizontal arm CMM for measuring the large body parts and structures. Then we have X-ray or computer tomography machines, form and geometry measuring machines. process control and inspection machines, and industrial microscopy solutions. So this is a bird's eye view of the Carl Zeiss, industrial quality solutions. And coming to the setup in India, this is our setup in India. In Bangalore, we have a headquartered in Bangalore, and in Bangalore we have a state-of-the-art technology center as well as the manufacturing facility. We have this kind of technology centers across India, in Delhi, in Pune, Chennai, Coimbatore, in all the major industrial areas we have a presence. So we have a pan-India presence with regional tech centers and also regional sales, service, and application teams. So today I'm going to talk about some of the applications, okay, the non-contact measurement solutions. Okay, I'm just slightly aligning my presentation to the present day trends, that is NEVs. Of course, these solutions are not can be used, of course, being already used for the conventional automotive or IC engine related applications, but also some of the products, okay, which can be used for the future technologies like NEVs, like it could be for power electronics applications, battery or e-motor and transmission casings, so on and so forth. So and second, I come back to this slide. So I will be briefly touching upon these products. So I will talk about X-ray or the computer tomography. This is the based on X-ray principle. Okay, how the measurements are being done, what are the typical applications. We'll talk about that. Then I will talk about the 3D scanners. Okay, which is again a non-contact. We have again different technologies to capture the complete surface topography of the part and some of the applications of it. Then I will talk about the multi-sensor CMMs, again optical and contact as well as optical based coordinate measuring machines. Okay, what are the variants we have, and what are the different applications of this machine. And lastly, I will touch upon the industrial microscopy. This again, of course, microscopy is again the way we look at the things through optical means. Yeah. So begin with X-ray. So what is X-ray? We all know X-ray is to see something which we can't see with our naked eyes. Yeah. So X-ray helps you to identify the hidden secrets in your parts, hidden defects in your parts. Which it could be cavities, it could be warpages, it could be pores, cracks, inclusions, and residuals. So Carl Zeiss has we have a at Carl Zeiss we have the complete wide range. We have, I would say, the complete the solution portfolio for X-ray is available with us, right from 2D X-ray machines to computer tomography machines and X-ray microscope for a high-end, high-resolution imaging applications. Then, of course, the software is integrated part of the system. We have image acquisition, image evaluation, and also the data management and industry 4 softwares are also available from Zeiss. They go in along with our systems. Then services, we have the measurement services applications for these X-ray services in India. We have these X-ray machines in Bangalore, we have in Pune, and also we have in Chennai. So the clients, okay, who wish to avail the services, okay, can do so by approaching us at the regular at our respective regional offices. And X-ray, coming to the applications, the where and all X-ray measurements can be used. X-ray measurements can be used in additive manufacturing, in aluminum casting, in blade manufacturing, in electronics, oil and gas, plastic parts, components. It is actually industry agnostic, this X-ray technology. Okay. So let me move ahead. Just to start, before jumping into the application, you might be wondering what is X-ray again, what are the different variants are what I'm showing here. So one is the 2D radioscopy, we call it as. Second one is the next level is the computer tomography and X-ray microscopy. So 2D radioscopy is nothing but a simple 2D X-ray. Here the 2D images of the parts are taken, and then it could be for a single shot, it could be multiple shot, but software helps us to, if the part is bigger, then software helps us to stitch those images and see where the internal defects are present in the part. It is simple it is only for an inspection purpose. Yeah. So typical application could be a wheel inspection to check once the alloyed wheels. Nowadays, okay, we see all these cars, automobiles and all, they come with the alloyed wheels, and it is necessary to check the internal cracks in those wheels. So it is not to quantify anything, it is not to measure anything, but it is just to see, before it gets assembled into the main vehicle, the OEMs want to check to ensure that okay, there is no internal cracks, because okay, when wheel rotates at a high speed, it should not cause any damage later. Yeah. So that is so for such kind of applications, 2D X-ray is used. Then comes the CT technology. Here what happens, the part being instead of taking only the 2D image, here we are taking the 3D image of the part. So how are we taking the 3D image? The 3D image is basically kept on the rotary table. Here there is the X-ray source and there is a detector here. Then the part is rotated on the high precision rotary table, and then we capture the multiple X-ray images, and these images are called as a voxel data, are then put together, and then we get the complete 3D voxel data of the part is available. So this is very I would say very dense information, and this data can be used for various metrology applications and for 100% inspection of the part. Now the higher end of the spectrum, we have X-ray microscopy. So here what happens, you can see here the part, the X-ray is beamed onto the part and it is being captured at the detector. But here, instead of directly being captured, if you are looking at a high resolution images, so we are combining our microscopy in this X-ray. So basically the X-ray images are again collated by our lens coupled with the detector, and that's how we are able to get a very high resolution images of the part. This is just a broad differences between the 2D X-ray computer tomography and X-ray microscopy. So let us have a quick look at so what are the products we have. I don't go in detail into all these products, but then just make a note that okay, we have the X-ray technologies available for lab applications as well as the X-ray technologies available for production line. So lab applications and all we use, metrotome is normally used. That is, computer tomography is normally used for a detailed analysis or detailed inspection, and high resolution X-ray microscope use. Whereas for production related, where a quick inspection is needed and where the cycle time is in terms of seconds, then we use these kind of Volumax machines, and then Bosilo make 2D X-ray machines. Okay, the applications are, one is metrology, as I mentioned. Now you have, once the part is scanned in an X-ray machine, you have got the complete in and out details of the part available. If I have a CAD model, then you can quickly superimpose and see are there any dimensional deviations. This is the metrology applications. And also since you have the internal data available right now, so you can measure all the internal structure which are not able to measure with a traditional CMM, for example. If you put the traditional CMM, then it measures only what it sees and what it touches. Yeah. So whereas with X-ray, you are able to measure all the internal structures or internal dimensions. The next application in broad from X-ray is the inspection. You can use the X-ray data to check the assembly defects. For example, if it is a water bottle, you can, or it could be medicine. So, and once it is content is filled inside this, then you have to check whether it is completely, the cap is completely properly sealed or not. Yeah. So how do you check it? So that can be checked by using these X-ray technology. Then joining technology control in case of welding or soldering. Then yes, as long as the material density is different, X-ray we can detect, we can differentiate the metal and then see how is the soldering or welding quality. So that is kind of an inspection application. Then failure analysis or a defect analysis can be done. For example, if it is a casting item or if it is a 3D printed part, and then you want to check, okay, are there any internal defects or voids in the part what you manufacture? Or in case of in traditional die casting, for example, before the part goes into a machining, you want to ensure that there is no pores or cavities in the line of the machining. So the part can be checked before it goes to a machining through X-ray, and then if the cavities or pores are there coming in the line of machining, or if it is not or if it is beyond well under control, only then you can pass that material for a further machining. Then this data can be used for wall thickness analysis also, like for example thin walled parts are there and you want to complicated parts, but then you want to check the internal, what is the thickness of the part. So all this can be done without destructive, without cutting open the part and then checking it. So in that way, X-ray helps in these kind of broad applications. One of the other applications which I quickly correlate with the previous presenter is the turbine or impeller applications. If you remember, there is something called an internal cooling channels will be there to check the internal cooling dimensions. Internal cooling is open or not, internal coolings are properly formed or not by using after part is 3D printed. So X-ray is the only solution. So for such kind of applications, X-ray is used. One of the applications just wanted to showcase to you. For example, this is the defect analysis of the casting part. Once the X-ray, these are some of the X-ray images, standstill X-ray images at different positions. And once we take the part images, by rotating it and then taking the complete images, this is how the data we get it. You can see here the complete in and out of the data we get it, and including any internal defects, for example, voids, internal porosity analysis, all those things, and you can quantify and you can measure all these things, and you can understand, okay, what is the spread of these defects, and subsequently you can take a call whether this is an okay part or not okay part, whether it can go in the assembly or not. This is one of the beautiful application of X-ray machines. Then X-ray machines also help you to accelerate your process in the prototype development. For example, if it is a switchgear, if you are into tool and die, or if you are into processing, or if you are into plastic manufacturing, parts manufacturing, or into electrical switchgears manufacturing, you can see here, okay, this is a simple switchgear, looks to be very simple, but then there are more than 1,000 dimensions need to be checked, before it goes to a mass production. So there are a lot of internal dimensions. The challenge is, okay, majority of the dimensions are internal. So if you need to open it, for example, when the first article comes, then if you need to check all these dimensions, then obviously you have to use various tools, like you have to profile projector, height gauges, screw gauges, vernier calipers, so on and so forth, and you have to cut open the part to ensure that, okay, all the dimensions are okay or not okay. Yeah, and this is really painstaking. This is how the drawing looks like, for example. Okay, and if you follow the traditional method, it takes easily 3 to 4 months. I'm telling you a very, very optimistic way. It takes 3 to 4 months for this switchgear housing to come out. To go to for a proved prototype part. Whereas if you use X-ray scanning, you can get these, all the internal dimensions at one shot. That is the biggest advantage, and you can drastically reduce, the prototype development, and within 3 to 4 weeks or maximum 2 weeks it can be done. The prototype can be proved out. That is one of the second application of the X-ray. So then the other applications could be like failure analysis. This is the assembled part of the X-ray. This is the assembled part. One of the assembled part, the medical part, and this is being defective. Means it is the insulin pen. When the patient presses this insulin pen, it is supposed to dispense the medicine, required amount of medicine to the patient. But then there is a defect. But then how do you check the defect? Okay, where it has gone fault like? One option is you have to cut open it, but then the moment you cut open it, the evidence is lost, and you may never be able to understand where the defect was, where the assembly defect was. So in such scenarios, okay, X-ray could be very handy, and you can see here when we subjected this part, when we measured this part in the X-ray, the not good part had a defect here. The center shaft was twisted, during assembly phase, and that could be very clearly brought out with our X-ray machine, and we could be able to find out the reason for this defect. So these can be corrected by the production department subsequently, effectively, without before it causes too much of damage, or before it is too late. Then coming to my next level of products is the 3D scanners. This is okay. What we saw right now is the X-ray, which is capable of capturing both inside as well as outside. Now we have the products, okay, that is called a 3D scanners, which are based on fringe projection system, that is the blue light technology we call it as, and laser technology. So these kind of portable and handle scanners are used for capturing the external topography of the part. For example, if you are again during the photo, these could be used during the for checking your validation, prototype development, or tools validation, or it could be used in the reverse engineering application, so on and so forth. So these are again with very high resolution, available in 6 megapixel, 8 megapixel, and so on and so forth. And in combination, ZEISS also offers the complete set of software. One is the GOM Inspect, which is capable of inspecting the data once the part is scanned. Then you have to scan. You have to do the inspection of the part more effectively, because this is a bulk amount of data, and you have to do the inspection of the part. So GOM Inspect is the software what we offer. Then GOM Inspect, the high-end software. Then ZEISS reverse engineering as well. Yeah. So where exactly the application of the 3D scanner? For example, okay, if you want to do a reverse engineering application, for example, this is the part. Okay, once a 3D scanner part is scanned, this is how you get the data. Then the GOM Inspect software helps you to generate an STL data with which you can quickly compare this with the CAD model and then see where the part deviations are there. Or it can be used for manufacturing the part, for generation of the CAD model. So there are two applications. One is reverse engineering, or it can be used for generating the CAD model. So this is the 3D scanners. Then the next set of non-contact applications I will talk about is the optical and tactile, that is laser, as well as not laser, sorry, optical and confocal sensors. So again, varieties of machines are available with magnifications ranging from 0.5x to 6.3x zoom with 12x magnification, and which comes with various light options to ensure that you can do the measurement of the part, edge detection and all with the high resolution images you can capture. And also these machines come with something called confocal white light scanner sensors, which are capable of measuring the depth measurements at with a very high precise accuracy. And these are the applications where we can use. You can see here where and all these non-contact CMMs can be used. It can be used for measuring the small aluminum profiles, rubber seals, plastic parts. It means you can't hold the part, or the part which are very flimsy, you can't touch and measure. So in those applications, these kind of non-contact measurement solutions can be used. Then lastly, coming to industrial microscopy, which are again based on optical or laser based. So we have a wide range of microscopy solutions available in our portfolio, right from resolution of 0.5 nanometer to 1 microns onwards. Yeah. So for the case of automotive electronics, or for the case of general electronics, there are these microscopies find various applications, like failure analysis or metallography can be used. Visual inspection can be application of visual inspection can be fulfilled with microscopy. Then can be used for optical measurement, surface characterization, and particle analysis. So what is visual inspection? Visual inspection is, as the name itself suggests, you can just check whether the part is okay or not okay decision. To take apart okay, not okay decision, this can be used. Then for failure analysis, you can use our light microscopy or electron microscopy or X-ray microscopy. Then metallography can be used, applications like, for example, to analyze the microstructure like in the batteries or in the material. So microscopies are used. Then particle analysis, that is technical cleanliness applications, microscopy can be used. Then surface characterization, and lastly optical measurement. Okay, you want to check the part like in the previous slides, to check the dimensional measurement of the part, this can be used. Okay. So I'm going a little fast on the interest of time. So this is one of the applications where a microscopy being used for checking the soldering defects. There are a lot of soldering defects going to happen in the electronics industry. Those can be effectively checked using our microscopies. Then the next level of application of microscopy is for checking the copper layer, because nowadays if you see any PCBs, there are a lot of multi-layer PCBs are being used. So at each of these layers, the copper is the layer, of course, being used. The quality of the copper has to be of the precise level, Otherwise, the PCB may not perform the intended operation. So how do they check it? Okay, they prepare a sample, they take the region of interest, they cut, they prepare a sample, and then the part is again subjected, measured using our extroscopy, analyzed, and then the various kind of defects or various kind of characters are analyzed using the microscopy. Another level of microscopy is for the electron microscopy application is in the same electronics applications, where once the PCBs are manufactured, then there is a layer of nickel or gold or is applied. But then again, because to ensure that the case solderability is very important, otherwise the case may lead to poor soldering and again malfunctioning of the whole of the PCB functioning. So again, in that applications, it is important to check the microstructure of these material layers what being put on the PCB. So electron microscopy is used in those applications. Very interesting for the semiconductor industry, for the semiconductor packaging, especially once the fab comes on a semiconductor, after the semiconductor fab comes, these fabs are cut open and then they are made into integrated chips, semiconductor packaging. So during packaging, there are a lot of defects are bound to happen, and these defects are to be detected only because these are very, very narrow, and this is where our X-ray microscopy comes into picture. So X-ray microscopy offers you a very, very high resolution, high contrast images through which you can detect even defects up to a nano level. It could be 50 nanometers or 60 nanometer is the kind of defect what we are talking about here. You can see here, these are literally, if you see in our phones, for example, the integrated chips are these are the this is the kind of testing being done using our X-ray microscopes. Yeah, so a small video just to give you an idea of what is this X-ray microscope is capable of doing. Mr. Manohar, if you could run the video. Yeah.
Imagine you want to investigate the inside of an apple on a Versa with resolution at a distance. You can get the microstructure of that seed without extracting it from the sample, without destroying your sample at all. You can extrapolate this to batteries, cell phones, natural resources, materials researches, bones.
When you cut up your sample, you can sometimes introduce damage that changes the very structures you want to see. So you really don't want to chop up your sample in order to get the high resolution imaging.
The Versa 600 series is the next generation of X-ray microscope from Carl Zeiss. It's a little bit like the Holy Grail, when you can get higher resolution and higher throughput without degrading reliability, actually improving reliability.
We have overcome the whole mystery of looking inside of a sample at high res, and there's nobody else that can do that. We can take the entire device and just put it in a pin clamp.
With the Versa 600 series, we've taken this incredible, unique, differentiating resolution at a distance capability, open up new applications that weren't possible for non-destructive imaging, and we've taken that, made it faster, made it higher resolution. We're basically extending this to places that weren't available before.
Carl Zeiss was one of the original inventors of microscopy centuries ago, and we continue that legacy today.
I look so forward to hearing the success stories from our customers as they make breakthroughs and discovering things that nobody's discovered before.
All right, so thank you, Manohar. So just bear with me. Just last two slides I have. Then the microscopies are being. We have microscopy for metallography applications as well. For this is used across industries, not only for. It can be used in automotive, general engineering, or wherever there is a metallography application is involved. To check the microstructure of the metal, to check the grain size, pores, cast iron analysis. So all these things can be done using our microscopy series of products. Then we have, lastly, we have the technical cleanliness solution. That is, in manufacturing, cleanliness of all the components is very, very important, and this has to be this is to ensure that the highest quality, and it has to be checked for the as per the standards like VDMA 19.1. So we have the a range of solutions available depending upon the particle size you wish to have, right from 20 microns up to less than 2 microns. So we have the solutions available for it, and this is how normally the technical cleanliness application is done. When the parts are produced, they are washed, and then the residues are collected using the filter, and that filter is again is measured using our the particles are studied with our microscope, and then you can check whether what is the inclusion of the material, what is the non-metal inclusion, what is the dimension of the part, so on and so forth. So this is in broad what I wanted to communicate to you, that we have the apart from our conventional contact measurement like CMMs and Bridge-type machines, so on and so forth, we have the solutions available which are based on optical, light-based or X-ray based solutions, which cater to the present-day needs of the high-quality precision measurement. In some cases, it involves non-destructive measurement as well. So with this, I end my presentation. Yeah, thank you once again for all your attention. Thank you.
Yeah, thank you very much. First of all, thanks to Mr. Seenivasan for his keynote address, and then I would also like to thank Markus and Mounesh. I think we had excellent presentation with good applications also. I think that was very, very important. We are running short of time actually, but we would just quickly we would quickly maybe just have one question. Maybe Mr. Seenivasan, would you like to put any questions to our speakers? Do you have any specific questions for them?
No specific questions. It was very well presented. Thank you both Markus and Mounesh for the excellent presentations. Yeah, a lot of questions have come to me. Probably I have my own requirements. Probably I'll just check with this gentleman separately.
Sure. Thank you.
Thank you. Yeah, we'll do this.
One question then, let me ask you, Markus. Do you think that the laser ablation process you have presented will reach to a point where conventional milling will be replaced by laser ablation?
Yeah, difficult question. So, of course, it really depends on the application. So, I think we already have reached a point where we can replace HSC milling, for example, by laser ablation. But the main point is you need to have the application in the focus. So I think yes, the innovation. Speed of innovation with the lasers is very, very high, and we already can see that laser machining is replacing conventional machining processes, and the same thing will happen also with HSC milling for some applications. Of course, whenever you are using a big tool, laser material processing or laser ablation still will be slower, no question. But if you remember these small and filigree details we were talking about and we were showing on the samples, then definitely yes, this will be the case. Laser will replace HSC milling or conventional machining in some areas.
Right. Thank you, Markus. Mounesh, I wanted to ask you, which sectors do you feel, Mounesh, as we go ahead, as maybe manufacturing becomes more modern, which are the sectors you feel will benefit from photonics or laser technologies in the coming period?
I would say, presently the automotive industry, of course, is automotive and general engineering industries are definitely driving the growth. But then going forward, I would say electronics is the one segment, and which would definitely benefit from these X-ray technologies. Yeah.
In fact, you'll be happy to know, Mounesh, today at our webinar, we have people from automotive sector, aerospace, pump, agriculture, machine tool, and automation sector. So in our audience, we have quite a good diversified group, and I think this web seminar has been highly beneficial for the participants. Maybe the last question is, or one question is coming. So maybe we will share the details. So people have asked your contact details. We will share the details when we send the presentation. We will share the details of the speakers. Maybe my last question to both of you, Mounesh and Markus. Markus, maybe you can, I would request you to start. The skill set requirement for the photonic industry. Do you think the industry has the requisite skill sets available, or in the next period we would need to enforce more skilling programs so that the people are fit for the laser technology or photonic industry?
Definitely, this is one of the things which is very important. You know, I always tell my customers, you can purchase the most powerful machine in terms of management level. If your operators don't like to use it, if they don't feel confident, if they don't feel at home, you will earn zero money. So definitely this skill set is one of the most important things we need to we need to solve. We need to train people on. So dependent on the technology, dependent on the product I have discussed and presented on, there is different requirements. Laser ablation actually is really simple. So it's more or less a push button solution. But if we talk about this hybrid manufacturing process, the combination of additive manufacturing with milling, with 5-axis milling, here the requirement of the operator would be to be a skilled 5-axis machine operator. And on top of that, he is then training or getting training for the additive side. So dependent on the product, different skill sets and levels are needed. But yes, the operator makes the difference.
Absolutely. Mounesh, would you like to share your thoughts also on this?
I completely agree with Mr. Markus. So X-ray, for example, has got a numerous possibilities to do more analysis, to more identifying the more looking the part more closer, and then see where the production challenges are. We can pick the production limitations. So in that sense, it definitely more knowledge and more skill development would help to use these kind of new technologies. And definitely once the skilled people are there, and start generating the various kinds of reports, definitely the companies will start finding the usefulness of these. Otherwise, these will be treated as kind of white elephants, kind of very high-end spectrum. It is not so. But then these machines pay themselves because looking at these technologies.
Right. Thank you, Mounesh. So with that, friends, we would like to conclude the web seminar today. I would again like to convey my thanks to Mr. Seenivasan, Mounesh and Markus, and also to my colleague Sandeep Roy, and all our participants, all our members and industry friends who have joined. As I said, we had a good participation from various sectors, and I think this is very encouraging that we had from various sectors. And also Mr. Seenivasan mentioned about agriculture industry and applications. So Mr. Seenivasan, we had some participation also from the agriculture industry. So friends, stay tuned with VDMA. Please follow. We have a series of webinars lined up for you, interesting webinars on the industrial application. So please follow us on our LinkedIn page. You will get the updates of our various events that we do if you follow us on our LinkedIn page. So everyone, stay safe, stay well, friends. All the very best. Thank you. Good night.
Thank you.
Thank you
so much. Thank you.